So we learned about distance equals rate times time yesterday, and we started with figuring out what kind of scenario we're dealing with.
One, get into the office, please, Mom.
Whether it is a round trip, and that was the skiing one, opposite direction, and that was the people bicycling towards each other, or the last scenario, how long did it take to overtake, same direction, yep, the helicopter and the airplane, okay? So the way I like to do these, if I'm being completely honest with you, is to say, what is the scenario we're dealing with, okay? So Juan left home on his bike at 10 a.m., traveling 21 kilometers per hour. At noon, his brother set out after him on his motorcycle, following the same route, traveling 63 kilometers per hour. What time did Juan's brother overtake him? So I'm just going to start by doing my little chart. I've got Juan, and I've got his brother. And I know that rate multiplied by time will give you the distance traveled. Okay? First of all, we know Juan's rate and we know Bro's rate. So I'm going to go ahead and put those in. Juan and Bro. And that's going to be multiplied by how much time they spent doing their gig. Well, like Ashley said, the first dude started at 10, but the other dude started out at noon, so how do you indicate that in terms of hours spent? Well, Juan, we don't really know how long he spent, so we're going to call him T. That's the time he spent traveling. His brother started out 2 hours later, which means he has 2 hours less time under his belt. Okay? Now, remember, we're talking about, so we've got Juan, and we've got the brother. Okay? Juan and the brother. So Juan left first, chugga, chugga, chugga on his little bicycle. And then after 2 hours, the bro left. At what point will he overtake him, otherwise known as catch up to him? Okay, so this is motion in same direction, and at the point at which he overtakes him is the point at which both journeys are equidistant. They're the same amount. Okay, so we are going to find Juan, he's 21t, and we're going to find the brother, 61t minus 2. And those two things equal one another. At what point will those two things equal one another?
Wait, why is it 61 and not 63?
63. I just didn't copy it right. Sorry.
Like,
Thank you.
I already studied that.
Nope, find my arithmetic errors. It's like, where's Waldo? Okay. All right. So now the equation will be 21t, which is Juan's traveling. At what point will Juan equal the brother? Okay, there we have it. We're going to distribute. Got this fancy new pen. Look at that. We're going to distribute, and we'll end up with 63t minus 126. All of that equals 21t. Okay, let's collect all of our t's to the other side. You're going to start thinking this is weird, but do not worry.
Yeah, that's where I got confused.
Don't worry.
I didn't get confused, I was just worried at first.
What's 21 minus 63 is negative 42. So now on the left I have negative 42t equals negative 126. Well, when you divide a negative by a negative, what do you get? You get a positive t. T equals 3. Okay. Now, let's use this to answer the question, shall we? At what point did Juan's brother overtake him? So we care about what point the brother overtook him. So we're going to plug in t as 3. 3 minus 2 is what?
Oh, so it's 1 hour after.
Uh-huh. The first dude started at 12. Or the first dude started at 10. I'm sorry, the first dude started at 10. The second dude started at 12. 1 hour later, he overtook him. So what time is that? 1 p.m. Awesome. So you took this to figure out the number of hours the brother was motoring, and that's when he caught up to him. Okay? That's our friend Juan and his brother. Okay. The next one. That's okay. I don't care. No big deal. These are not quick and easy. Not yet, anyway. A jet flying at a constant speed took 5 hours to fly from Frisco to St. Louis. I don't know. I folded it wrong. 2 planes leave Chicago at the same time. One flying east at a rate of 550 miles per hour, and another one left Chicago flying west at a rate of 650 miles per hour. Okay, they both leave at the same time, so it doesn't matter. They both left at the same time. How long does it take for their combined distances to equal 2,000 miles? So at what point does him traveling added to him traveling away from each other equal that amount? Yes. So this is same direction, right? Well, yeah, but same direction. So this problem is a traveling in the same direction. I'm sorry, traveling in opposite direction. Jeepers creepers. Opposite direction. Okay? But we're still going to use the same scenario. We're going to do east versus west, so to speak. East and west. And we're going to do rate multiplied by time equals the distance traveled. We know the eastbound guy is 550.
Attention students, we found a watch underneath the bleachers yesterday. If you are missing a watch, please come to the office sometime today or tomorrow and see if that's the one that we found. Thank you.
They both leave at the same time. So that means the amount of time spent is the same. Would you agree? Yep. Because they both took off at the same time. It's like me and you back to back. You walk that way, I walk that way. How long would it take at your speed of 650 and my speed of 550 before we would be 2,000 miles from each other?
Well, what if?
We both started and stopped at the same time.
Well, not necessarily stop, but there was a line drawn mentally at what point are they 2,000 miles apart. Absolutely, but it doesn't matter. All we want is for the miles covered by the eastbound plane and the miles covered by the westbound plane when added together to total 2,000 miles, right? Yeah, I'm going to talk about trains. So, the distance of the eastbound flights traveled, miles per hour times time traveled, added to the distance of the westbound flight traveled. At what point, how long will it take for them to cover a distance of 2,000 miles? So this is opposite direction, and we're trying to cover a total distance using 2 vehicles. At this point, we combine like terms, which, if I'm doing my arithmetic right, should give me 1,200 t equaling 2,000, right? Divide both sides by the coefficient. What do you get, Katie? That's okay.
1.6.
With repetent, so 1 2/3 is what it sounds like she's saying. 1.666666666. Okay? It would take 1 2/3 hours traveling at these rates for these two planes to now be separated by a distance of 2,000 miles. 1 2/3 hours is also 1 hour 40 minutes. That's how long it would take. Okay? All right. I'm going to dump number 3 because I really want to get back to yesterday's assignment. Were there any in particular or just like all of the above? Okay, so I will do as many as I can for like 15 minutes. Hurry though.
I think the only one I didn't understand was number 7.
Okay, I'll make sure I get to number 7 and I'll do as many other ones, okay?
And I got home. And I got in the car.
It's okay, Percy.
I looked at my notes. I was like,
Okay, so here we go. You guys want to start with number 1? I got to make sure I get number 7 though. So number 1 in the written exercises says complete the solutions of the oral exercises. So that means we're going to open our books to page 169. Okay. And we're going to start with the first oral and actually solve it. Okay. At noon, a private jet left Austin for LA. So we've got, I'm just going to draw a little bit. Austin to LA. Left at noon. Flying at 500 kilometers per hour. The distance between these two places, by the way, it looks like they told us, is 2,100 kilometers. And the guy departed at, lost my place, noon, whatever that is. Okay. 1 hour later, a flight left LA, bound for Austin, and 1 hour later. And this particular guy was traveling 700 kilometers per hour. At what point did they pass each other? Now, as weird as that sounds, it is the same thing as the one we just did with the trains, planes. Okay, it's the same thing. At what point did the flight from Austin to LA wave and pass the flight from LA to Austin? Okay, which means his rate times whatever time he traveled added to his rate times the t minus 1 has to total the 2,100 kilometers worth of distance between the two origins. Okay? So if I were to chart this, I would say A to L and L to A. I'm going to squeeze it in. R, T, D. Austin to LA is doing 500 kilometers per hour, and he started at T o'clock. LA to Austin is doing 700 kilometers per hour, and he started 1 mile later. Okay? So the first plane, rate times time, is 500 T. His traveling ability added to the other guy coming right at him, which is 700 T minus 1. At what point, after how many hours, do the two planes meet and then pass on their way to their corresponding destinations? Okay? So this is number 1. Finishing it up here, 500 T plus 700 T minus 700 equals 2,100. Put a 1 there, please. Okay. looks like we got 1200 T. I'm going to add 700, okay? Add 700 to both sides. 1200 T equals 2800. Does everybody see how I squeezed that in there? I combined these two terms, and then instead of writing another line and then adding 700 to both sides, I just did it shorthand. I added 700 here, so I added 700 here, which turned 21 to 28. Now I'm going to divide 2100 or 2800 by 1200. And I will find out what T is. Oops, that's not right. It gives me that ain't right. Try it. Let's try this again. 2800 divided by 1200 is 2 and a third. The 3 thing that you can't see is a third. So that means time is 2 and 1/3 hours, otherwise known as 2 hours, 20 minutes. Now let's look at the question again. At what time did they pass each other? At what time did they pass each other? Well, the original adventure started at noon. Add 2 hours and 20 minutes to it, the answer becomes 2:20 p.m. Okay, this is number 1. All right. Number 2. Number 2. At 8 a.m., the Smiths left a campground driving at 48 miles per hour. 8:20, which is 20 minutes later, the Garcias left the same campground and followed the same route at 60 miles per hour. At what time did they overtake the Smiths? This is very similar to the helicopter and the plane from yesterday. Okay, motion in the same direction. This is motion in the same direction. So we've got the campground, and we've got the Smiths, and we've got the campground and the Garcias. The Smiths left at 8 o'clock, going 48 miles per hour. So I'm going to call it T for the time traveled. That's hours spent. 20 minutes later, the Garcias left, going 60. Now 20 minutes later is a third of an hour. You have to keep it hours for hours. You can't say T minus 20 because that's T minus 20 hours later. Okay? At what point will the Garcias catch up to and equal the distance traveled by the Smiths? Which means, at what point will the Smiths' time traveling equal the Garcias' time traveling? Okay, and we're talking about distance here. So, let's go ahead and distribute. And you should end up with 60T minus, what's a third of 60? Looks like it's 20 equals 48T. This is another one where you're going to have a negative situation, but when you divide, it won't be an issue. So we're going to subtract 60. And what did I get? Negative 28? No. Negative 18? No. Let's do this on here because I'm going too fast and I can't think straight. Let's try that. How about negative 12? Says the math teacher. Okay. Negative 12t equals negative 20. Divide by a negative. And you end up with the amount of hours being whatever the result of 20 divided by 12 is, which looks like 1 2/3, which you came up with 1.66666. Okay, 1 hour, 40 minutes. Let's see if that answers the question, though. At what time did they overtake the Smiths? Okay, at what time did they overtake the Smiths?
Yes.
Okay. So if the original adventure started at 8, this is when these guys started. But these guys didn't start till 9:20, right? Their start time is 9:20. Try 8:20. Those guys started at 8:20. 1 2/3? Did I do arithmetic wrong somewhere? 60 and 48. 60 and 48. 48t, 48t, 60. A third of 60, that's 20. 20 divided by 12. 1 2/3, which is 1 hour and 40 minutes. Ah, indeed. Okay, so the original adventure started at 8 o'clock. Add 1 hour and 40 minutes to it. 9:40 a.m. When they give you time that has passed, it's basing it off of when the original scenario began. Okay? Sorry, I had to second guess myself there.